Hi gents, welcome back over Easter. Hope you had a good break. Um, what I'm going to do today is I'm going to do question 6 from exercise. I think it's 4C. Yep, it is indeed. Some of you just emailed just to ask me if I would just go through it, which is a good sign that you're trying these things out. I'm going to try to do more videos than what we did just before Easter. I wasn't feeling great, if I'm totally honest with you. So I want to just go a little faster than what we did the last day. So yeah, look, let's start off with it. We'll do question 4. Hopefully you or sorry, question 6 from 4C. Hopefully you gave this a shot yourself and tried it out. If you didn't, now is definitely the time to do it, as opposed to seeing me do 2 examples and you doing none. So get cracking with it. Okay, here comes question 6. It says 2 straight roads intersect at a point O and cross at an angle theta to one another such that tan of theta is equal to 3/4. The 2 cars A and B are traveling towards O on these roads at 10 meters per second and B at 20 meters per second. So we'll just do a quick little diagram of this thing here. This is O, and B is here. There's a 100-meter gap, and it's traveling in that direction, which I think was not the direction it was in question 8, which was the example that I gave you. So it is a little bit different to that one. So this is going at 20 meters per second, and A up here, it's also a 100-meter gap, as it happens, and it is going at 10 meters per second. Per second. Yeah, perfect. Okay, so what we want to do is we want to write down a couple of details here. We want to write down the velocity of A and the velocity of B. So velocity of B, it is headed, this time it's headed left. So you've got to be a little bit careful there, and it's doing 20 meters every second, just directly east, if you want to think of it like that. So that's minus 20 i's because it is going left, and 0 j's. Okay, velocity of A, a little bit trickier. Just remember it's our u cos theta plus I sine theta. And that is our I and our j vector. So what we want to do in this case is we just want to use what we were told. We were told that the tan of theta is equal to 3/4. Now you should be able to do this in your head, but let's just say you can't. You would do theta there. You would say that's 3/4 opposite over adjacent. That's that. Use Pythagoras' theorem to get that that is 5. And from that we can say what's the cos of theta? Adjacent over hypotenuse 4/5. What's the sine of theta? Opposite over hypotenuse 3/5. So we can just fill those in. VA is equal to, what's it doing? It's doing 10. So it would be 10 cos theta, so that's 10 times 4/5 I, and 10, I don't know why I wrote 10 I there, sorry, U, should have written down. U sine theta is 3/5. Now there is a little bit more to this, we'll just think about it. To get the signs correct, what is A doing? Well, A is really, it's going, when it's doing this, it's going left and it's going down. So it's going left and going down. Make sure you get the signs right. It's going to be minus I because it's going leftwards on the i's, and minus j's because it's going downwards there. So what's that? That's going to be minus 8i, and it's going to be minus as well, and that is going to be 6j. Okay, so there we go. We have our 2 equations there. And just like the last time, you get the velocity of A relative to B. So that's velocity of A minus velocity of B. The only thing that was different from the last time was the sign. So they were going in different directions the last time. So you just need to be careful that you need to watch out for it. And I suppose over on the diagram I should also indicate which way A is going, because that does make a difference. And obviously if the signs are different, then the whole thing is totally different. So velocity of A given B. So we take velocity of A, that's that, and we subtract off B. So we're going to have minus 8i, and we're going to subtract a minus 20i, so that's plus So we'll just get 12i, and we have minus 6j's, and we're going to take away nothing, so we'll just get minus 6j's there. Okay, that is what the velocity of A given B is. The next thing to do, if you remember, is from this scenario here, okay, this one that we're talking about here, what we want to do is we want to let time go on such that they are in line with each other. Okay, so perfectly in line horizontally with each other. So if we just think about that, if it's going 10 meters per second and it's got to travel 100 meters, obviously that's only going to take 10 seconds. The other one, actually B, if it's going 20 meters per second, it's only going to take 5 seconds. Now, we don't want to let things run on for 5 seconds, because what will happen is that B will end up there, but A will only be halfway along here, and they're not in line with each other. So we don't want to let that happen. Instead, what we want to do is we want to let A continue all the way here. That's 10 seconds. In that time, B will have gone there, and the same out the other direction again. Okay, it'll have just clearly gone 100 meters out the other direction. Okay, so the numbers are nicely done there. So let's actually just draw in what that is going to be like now. This time I'm going to need to maybe just bring O over just a little bit over here instead. So that's going to be O. Now this is currently where A has got to. Okay, so what we're really thinking of there is we're thinking of this having gone there. That's taken 10 seconds for that to happen. And inside that time as well, B is going to go there in 5 seconds and the same distance and direction again. So B is going to end up over here. And it is, of course, going to leave a gap of 100 meters. Okay, so hopefully you've figured out what that means. We've let 10 seconds go on. I might just say that maybe here after 10 seconds. Maybe I'll write it here, because we'll need that after 10 seconds. This is the scenario. Whoops. Okay, there we go. So hopefully you understand exactly what's happened there. A is gone, your 100 meters. B has actually traveled 200 meters inside that the same time. So they're now in line with each other horizontally, which is precisely what we wanted to happen. Okay, now we're going to use the piece of information that we had over here, which was that 12i minus 6j. If we think about that, that is what is A doing relative to B. So if we hold B still, what does it look like A is doing? Okay, and what it looks like at this particular moment, in fact at all moments this is what it would look like, but at this particularly important moment this is what it looks like. It looks like that if we keep B still, A, every single second looks like it's moving over 12 and going down 6. So if we kind of just draw that in there, it looks like it's moving over 12 and that it's going down 6. Okay, half that or so. So what it really looks like A is doing is it looks like that A is doing that, where that bit is 12 and that bit is 6. That's the ratio of what A is doing. Okay. And it also means that what it was doing beforehand was it was coming from there as well. And specifically when it asks us what is the shortest path, okay, what's the shortest distance that they were at, that A and B were at, this is going to help us get it. Okay, shortest distance obviously means perpendicular distance. So what we're trying to find out here is we're trying to find out what's D. What is that perpendicular distance there? Okay, and this is all the information that we have. We know that this guy is 100. We don't know too much else, but we can figure out what is theta in this particular case here. Okay, theta. Well, we know that we have 6 being the opposite, 12 being the adjacent, so we can say that tan theta is equal to 6 over 12. So theta is equal to tan inverse of a half. Let's type that in. Okay, so it comes out to be, if we actually put it in, tan inverse of a half, comes out to be about 26.565 degrees, we'll say that. Okay, and of course, this is the same angle there, theta. Why is that the case? They're vertically opposite angles to each other. So they have to be the same as each other. And now it's fine. We can actually figure this out. If we know what theta is, well, in relation to theta, d, the thing that we want, is the opposite, and we have the hypotenuse. So opposite and hypotenuse is sine. So sine of theta is equal to opposite d over hypotenuse 100. So we get 100 times the sine of theta, and we've just got what theta is. So actually, you can just keep it in your calculator from when you did it there. So it's about 26.565, but if you wanted to be really accurate, you just use the ANS button from before. So we say it's 100 sine ANS, press equals, and we have that d, the distance is 44.7213, blah, 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 but we'll just do it to 2 decimal places. There we go. That's going to be our answer. That's the shortest distance between the two. And if we just check, is that exactly what they were looking for? Yeah, it is. Okay. So that one was just like the time before. Just remember what the tricks are. Write down velocity of A, velocity of B, then one relative to the other. Pay close attention to the signs. Very easy to get one of those wrong, and then it all goes horribly. What you do then is you let the situation play out until A and B are both horizontally in line with each other. And from there, then you're going to be able to figure out what is theta, and you're also going to be able to figure out what's the shortest distance. Okay, what we'll do is we will stop there. I'll make a second video there of a new topic. Well, new topic, whatever. Moving on from what we were just doing. So yeah, hopefully you found that useful, and please do keep giving me feedback and all the rest of it. Okay, gents, take care. All the best.